right, last topic. Let's see how to find the inverse of a function defined by an equation. In the previous section, we talked about the graph of a function and the graph of its inverse. They're symmetric with respect to the identity function, right? So that's the theorem. So now let's see what if the function defined by an equation, how to find its inverse. 3 general steps. Okay, first step, okay, when we write as y equals f of x, we interchange the variable x and the variable y. Okay, interchange x and y, that's the first step. Second step, we solve for the y in terms of x. Okay, and then that is the inverse function, solve for the y, because we already switch x and y, right? And then solve for the y, and then that is the inverse function. And then step 3, we use composite functions property to verify whether they are inverse functions or not. So now let's look at a specific example. All right. So we got a f of x equals 2x plus 1 over x minus 1. So we can write f of x is same as y, right? We can write y equals 2x plus 1 over x minus 1. And then swap x and y. So that's when we see variable y, we write as x. When we see variable x, we write as y. Okay, that's the first step. X and y swapped. And then second step, we want to solve for the y. Okay, solve for the y. So we both sides multiply by y minus 1. So y minus 1 times x equals 2y plus 1, right? So we get rid of denominator and then simplify. We got xy minus x equals 2y plus 1. Okay, remember our goal is solve for the y. Okay, we try to solve for y. That is our inverse function. So how to solve for the y? We need to move all the y term to the left-hand side, right? All the x term to the right-hand side. X term and the constant term. So we subtract 2y on both sides of the equation and then move the x to the other side. And then we have xy minus 2y, right? And then this one cancel, right-hand side, we have x plus 1, right? And then we factor x minus 2 out, times y equals x plus 1, and then both sides divided by y minus 2. So we got a y equals x plus 1 over x minus 2. And the domain of the function x cannot equals 2, right? Make sure denominator cannot be 0. Okay, so the inverse function of original is x plus 1 over x minus 2. Okay, right here. Now we just substitute y by inverse function symbol. All right, third step, we want to verify. Okay, see f composed with its inverse, whether it equals x or not, and then do the other way around. So let's try. Okay, function, original function is outer function, and then the inverse is the inner function, right? And then we substitute the inverse function. Yes, what we have? We have x plus 1 over x minus 2, right? And then plug into the original function. That's 2x plus 1 divided by x minus 1, right? And then replace x by the inverse, which is x plus 1, x minus 2, x plus 1 over x minus 2. All right, and then both sides multiply by x minus 2, right? Both numerator denominator times x minus 2. So we have 2 times x plus 1 plus x minus 2. That's numerator. Denominator is x plus 1 minus x minus 2, right? And then that's equals what? Let's see. numerator we get what? 2x plus 2, right? Plus x minus 2. Denominator, x and minus x cancel. 1 plus 2 minus negative, that's a plus, right? It becomes 3. So numerator, the constant term cancel. We got a 3x over 3, which is x. Okay, so we have to do the other way around, which is f inverse composed with f. Okay, and then we have inverse function is outer function, f of x is the inner function, right? And then we can plug in what is the f of x inner function, which is original 2x plus 1 over x minus 1, right? And then plug into the outer function. Outer function is x plus 1, so x plus 1 over x minus 2, right? X plus 1 over x minus 2. And then what is x? X is 2x plus 1 over x minus 1, right? 2x plus 1 over x minus 1. And then same thing, both numerator and denominator multiply by x minus 1. So we have 2x plus 1 plus x minus 1. And then 2x plus 1 minus 2 times x minus 1, right? So numerator plus 1 minus 1 canceled. We only have 2x plus x, that's 3x. Denominator 2x minus 2x cancel out, and then 1 minus negative 2 becomes 3, and then simplify x. So now we verify, this is the inverse function of original. Okay, we got it right. All right, and then you can watch the solution page. You should the same process. All right, let's try one more. Y equals x squared, square function. We're trying to find its inverse. Okay, first switch x and y, so x equals y squared, and x greater than equal to 0. Okay, that's the domain. And then square root function, right? We're trying to solve the y. Y equals, is supposed to be, if x is our real number, it's supposed to be plus or minus square root of x, right? Now only restricted, x is a positive number, that's why we only have positive square root of x. All right, so now let's see. This is half of the parabola, right? And then the square root function, we know square root function is like that, right? So we can verify actually they are symmetric with respect to the identity function. Okay, this is x squared function. This is a square root function. Okay, they are inverse functions. So that's the better graph. So these two functions, they are both the function in our function library. Okay, at that time, we didn't notice, okay, these two are inverse functions. So now if you look at the graph, just to verify, right, the half right-hand side of the parabola, half of the parabola, and square root function, the graph, it is symmetric with respect to the identity function. So they are inverse functions. So that is the section 6.2 we finished today.